This lesson is going to be about oxidation reduction reactions, part 1. And remember that an oxidation reduction reaction is common in single replacement reactions, synthesis reactions, and decomposition reactions. And so you will always be using this method for any of those 3 reactions. So there are a couple of things you need to remember. First of all, if an element is by itself, or if a diatomic atom is by itself, it has a 0 charge. So here I have a chemical equation where we have calcium with oxygen combining to become calcium oxide. Because calcium is by itself, we know that this has a 0 charge, and I like to sort of write the charges on top for myself. And this oxygen, O2, even though you have 2 of them, because it's diatomic, it also has a 0 charge. Calcium oxide is written together, which means that it's bonded together, so this calcium is not by itself and the oxygen is not by itself, and so that has the typical charge. And calcium, if I look at the periodic table, has a +2 charge, and oxygen has a -2 charge. So the thing that I like to remember for oxidation reduction reactions is we need to figure out which one is being oxidized and which one is being reduced. And the way that I remember it is by oil rig. Okay, so oil stands for oxidation. That's an I. Is losing electrons. And rig stands for reduction, is gaining electrons. And we can figure that out based on the charges. So if I look back here at my calcium has a 0 charge and then becomes a +2 charge. So it's becoming more positive. So what's happening in terms of electrons? In order for anything to become more positive, it needs to lose those negative electrons. So that means that the calcium is losing electrons. So I write calcium is oxidizing. All right? And the way that I can is simply because we have calcium with a 0 charge becoming calcium with a +2 charge. And I would write it that way. I would actually have no charge be over here because it's assumed that it's a 0 charge. Now the other way that I can write this is actually show that by an image. And the way that I like to do that is pretend I have a hand that can throw electrons. So calcium is losing its 2 electrons, it's throwing away its electrons. So we would look at it as this way, that it's thrown its 2 electrons out, so you have calcium +2E. We call this a half reaction. Okay? So let's do that for oxygen. If one is oxidized, the other one is going to be reduced, and in fact it is like that. So you have oxygen that has a 0 charge, and it becomes more negative. And the only way that it can become more negative is if it gains those negative electrons. So oxygen, O2, is going to be gaining electrons because it now has the -2 charge. And we can just actually keep it like this. So it has a 0 charge with the other one. Because it's gaining electrons, we say that it's adding 2 electrons to it. We add those electrons and end up with a -2 charge. This is also considered a half reaction. So this is where oxygen is reduced. Great. So let's go ahead and try another one. So for the next one, we have iron and copper sulfate and you have the product of copper with iron sulfate. So we want to make sure that we balance it. We do that by adding the big numbers in front. And pretty soon you notice, oh, this is an A, this is an B, C, this is B, this is A, C. And so I can tell that this is a single replacement equation. So I'm going to do the same thing. Remember, if it's by itself, it has a 0 charge. So this iron is by itself. This copper is bonded together with a sulfate. I know that the copper has a +2 charge. I know that because it's bonded together with the sulfate. When I look at the polyatomic chart, sulfate has a -2 charge. So those will balance out. Copper here has a 0 charge. And the iron is bonded together with the sulfate, so it's not by itself. This here has a +3 charge. I know that just because the sulfate has a -2 charge, and there need to be 2 irons to have a total of a +6 charge, and 3 sulfates to have a -6 charge to equal 0. So we're going to break down this equation like we've done with the other equations. So for this one, I know that 2 irons have a 0 charge. So I leave it blank. I'll put a 0 there just for your sake, but normally you wouldn't. Plus 3 coppers that have a +2 charge. Plus 3 SO4s, which have a -2 charge. Okay? This copper over here, because it's by itself, has a 0 charge. We'll put a 0 there. And the iron has a +3 charge. I have 2 of the irons. I have 3 of the sulfates. They have a -2 charge each. All right. So now, similar to what we've done before, this is our full or total ionic equation. What I'm going to do now is I'm going to cancel out the things that did not change. So I look at the iron, and it has a 0 charge. It actually changed to have now a +3 charge. So that clearly changed. The copper had a +2 charge, and when I look at the product side, it has a 0 charge. So that one definitely changed its charges. The sulfate did not change. It has a -2 charge and a -2 charge here, so we cancel it out. Those actually didn't change in the reaction. So I can say that my net ionic equation is 2 irons plus 3 copper plus 2 with 3 copper. Remember, we don't put a charge here because it has a 0 charge, plus 2 irons with a +3 charge. All right, so this is what I'd like you to do with all of those problems that I have given you. The next thing that I want you to do is tell me which one was oxidized and which one was reduced. So you take one of these and you look at it and you're like, okay, iron has a 0 charge and it becomes +3. And I remember my oil rig. So you remember that if it loses electrons, it is considered oxidation. If it gains electrons, it is considered reduction. And if you lose electrons, it means you're becoming more positive. So this one here was from 0, becoming more positive being 3. That only way that it could be more positive is if it lost those negative electrons. So iron is oxidized. Okay? We can even write a half reaction if we want to. That means that 2 iron threw those electrons away. Remember, this is just like a hand. To become 2 positive electrons. With, in this case, we are going to say that it threw a total of 6 electrons away. Okay? to make those charges, or we can say 3 electrons, okay, for each. All right, next thing. Copper, if one is oxidized, then the other one is reduced. Copper is reduced. And I know that because here I take a look at copper, has a +2 charge, and it becomes more negative to a 0 charge. The only way it can get more negative is if it gains that electric negative charge, and so that is being reduced. So copper is reduced. I do the same thing. Copper has a +2, and because that we have 3 coppers becoming 0 each time, those 3 are losing, for the half, you have 3 coppers with a +2 charge. They get 2 electrons, right? And then they become 3 copper. And that would be a half reaction. The only thing I want you to do for homework is this section right here and identify which element is oxidized and which is reduced. We won't worry about the half reactions until in class.